let's review long division, which we learned back in elementary or even middle school. So we have 60,125 divided by 125. So inside, we have 60,125, and on the outside, we have 125. It's good to know that this 125, is our divisor. 60,125 is our dividend, and our answer will be our quotient. Terms to know. Alright, so first thing that we're going to do is we're going to ask how many times does 125 go into 6? It doesn't. How about 60? It doesn't. How about 601? 601 divided by 125 goes in 4 times evenly. So I'm going to put a 4 above that. 4 times 125 is 500. So I'm going to line that up underneath and I'm going to subtract. 601 minus 500 is 101. Next, I'm going to bring down the 2. Now I'm going to repeat that again. How many times does 125 go into 1012? Goes in 8 times evenly. And 8 times 125 is 1,000. Subtract. I have 12 left over, and then I'm going to bring down the 5. And 125 goes into 125 one time. So 60,125 divided by 125 is 481 with no remainder. So now we need to do this with polynomials. So our divisor is x minus 3, and our dividend is 2x to the third minus 8x squared minus 4x minus 6. Notice that our dividend is in descending powers. So we always want descending powers, meaning our exponents go from high to low. If they are not, you need to always rearrange. We're going to do the same concept that we did up above. So I'm going to start with this x minus 3 on the outside. I'm going to focus on that x. I'm going to say how many times does x go into 2x to the third? X times 2x squared. So I'm going to line up my exponents. Right? So this squared here goes up here. So x times, now I'm going to multiply this whole thing times what I put up top. So if I do it out on the side, and I distribute, I get 2x to the third minus 6x squared. Notice that my exponents line up. Follow what I did above. I'm going to subtract the whole thing. So 2x to the third minus 2x to the third, those are going to cancel, and those should always cancel. If they don't cancel, you did something wrong. And then I have minus 8x squared minus, so I have minus 8x squared minus negative 6x. So this really becomes a plus here. Negative 8x squared plus 6x squared is going to be negative 2x squared. Bring down the next term just like you did before. I've gone through that once, now I'm going to repeat all those steps. How many times, so I'm going to look at this x minus 3. How many times does x go into negative 2x squared? Negative 2. So I'm going to put negative 2x up top. My exponents line up. I've got a 1 here and a 1 here. Now, so I'm going to multiply my negative 2x times my divisor. When I do that, I get negative 2x squared plus 6x. Remember, I'm going to subtract the whole thing. Negative 2x squared minus negative 2x squared, those are going to cancel. Minus 4x minus positive 6x will end up being negative 10x. And I'm going to bring down my minus 6. Again, I'm going to repeat all of that. So how many times, or x times what would give me negative 10x? And that'd be a negative 10. And I'm going to take that negative 10 and I'm going to multiply it by my divisor. Negative 10x plus 30. I'm going to subtract the whole thing. Negative 10x minus negative 10x, those cancel, so I know I did it right. Minus 6 minus 30 is going to be negative 36. I have nothing left to bring down, so that means that this negative 36 here is a remainder. And we are going to write that as we have 36 pieces of that x minus 3 left. Remember that if that was tough to follow, you can hit rewind, and watch it again. Keep in mind that you need to be pretty comfortable with long division. So if you are not, maybe try some basic long division problems again. All right, let's try number 2. We have 8x to the third plus 2x squared minus 51 divided by 4x minus 7. Notice here that I didn't have any x's, so I could really fill that in there with a 0x. I need to hold my place. So if there's nothing there, you have to fill it in with the exponent. And again, notice that I am in descending powers. Step 1, I'm going to ask myself, 4x times what gives you 8x to the third? That would be 2x squared. So I'm going to line up my exponents. And now on the side, I'm going to distribute 2x squared times my divisor. When I do that, I get 8x to the third minus 14x squared. Subtract that whole thing. Notice that I've been putting that whole thing in parentheses, so it's easy for me to see that I need to distribute. 8x to the third minus 8x to the third cancels, and 2x squared minus negative 14x squared gives me 16x squared. Bring down the 0x and repeat the process. 4x times what gives me 16x squared? Well, that would be 4x. Notice that my exponents here line up. Distribute to my divisor. And I get 16x squared minus 28x. Subtract that whole thing. The 16x squared minus 16x squared cancels. 0x minus negative 28x becomes positive 28x. Bring down your 51. Last time, 4x times what gives you 28x? That would be a 7. Distribute that. When I do that, I get 28x minus 49. Subtract that whole thing. Negative 51 minus negative 49 ends up being negative 2. So again, my remainder is negative 2. So I'm going to write that as 2, negative 2 over my divisor. Long division, or synthetic division, which we do later, is going to help us with our polynomials in the long run. Remainder theorem says if a polynomial, f of x, is divided by x minus c, then the remainder is f of c. So what does that mean? So that our example, we have f of x equals 2x to the third minus 8x squared minus 4x minus 6, and we want to find f of 3. This really means we have x minus 3. So I'm going to divide 2x to the third minus 8x squared minus 4x minus 6 by x minus 3. Let's see what we end up getting. Now is a good time to hit pause and then check your work with what I do. So my quotient was 2x squared minus 2x minus 5 minus 21 over x minus 3. My remainder here was negative 21. So using the remainder theorem, what this really tells me is that if I evaluate my function at f equals 3, so 2, 3 cubed, minus 8, 3 squared, minus 4 times 3, minus 6. Go ahead, enter that all into your calculator, and you should end up with negative 21. The remainder theorem and eventually the factor theorem are going to be pretty important for us. What do you think we want our remainder to be that would tell us that our x minus c is a factor? Let's try some examples. Number 3, so we're going to find f of 2. It's actually a good idea for you to practice your long division, so do it both ways. X minus 2, 3x cubed minus x squared plus 5x minus 4. Go ahead and do long division. And then we're also going to check, or we could do it first, plugging in 2 and seeing what we end up with. And then we can check that we did it correctly. Here I get 26. So using long division, I want to make sure that I get 26. So go ahead and do the long division and check your answer with my work. You can see from my work that I got a remainder of 26, which matches up with what I did for the remainder theorem. Same thing, go ahead and try number 4. Check your answers with mine. Using the remainder theorem first, I got 0 as my remainder. That's going to be important for us. Just checking, so since this is f of 3, using long division, my divisor is x minus 3. Notice that again, using long division, I get a remainder of 0. So why is this important? Well, the factor theorem tells us that a polynomial f of x has a factor x minus c if and only if f of c equals 0. So that means if I get a remainder of 0, my divisor is going to end up being a factor. Think about why that's important. Why is it important to know the factors of a polynomial? Well, this will be helpful in finding factors, so we can graph pieces of our polynomial. This is going to be especially helpful for us when the techniques we know don't seem to work. So if we start with something we don't know how to factor, we can now use the factor theorem to figure out whether or not certain numbers are factors or when we graph intercepts. So, example, show that x minus 2 is a factor of f of x equals x to the third minus 4x squared plus 3x plus 2. Well, we can combine the remainder theorem and factor theorem here. So, this is asking us to find f of 2. So, plug in 2 anywhere I see an x. And when I do that, I get 0. So we know that x minus 2 is a factor of this polynomial. So if I went to sketch it later on, I know that one of the zeros would be here. And look here, I can tell that the y-intercept is 2. So I know 2 points of this graph so far, based on what we know.